These are pre-algebra notes for section 1-7. We're going to look at a few more properties of integer exponents. So we've got this key concept, and we will be able to use this once we've learned the rules. So the rules we're going to learn today are for the zero exponent property and the negative exponent property. So our first example is discovering the zero exponent property. So we're going to use expanded form. So we see our first example, we have 2 to the third over 2 to the third. And when we expand both of those exponential expressions, we're going to write 3 copies of 2. So 2 times 2 times 2 over 2 times 2 times 2. And then we can cancel vertically because 2 over 2 equals 1. So that leaves us with 0 copies of 2, giving us a final answer of 1. And if you use the rule, you are just going to subtract the numerator exponent minus the denominator exponent. So 5 to the 7th, if we write this out, we're going to write 7 copies of 5. 1, 2, 3, 4, 5, 6, 7. And again in the denominator, 1, 2, 3, 4, 5, 6, and 7. And when we cancel, 5 over 5 is 1. So all of those equal 1. And look, it looks like a 1 when I cancel them. So when we eliminate, there's nothing left there. So I'm just going to leave that one blank, actually. And that would be, I'm going to put 5 to the 7 minus 7. So 5 to the 0, that's going to equal 1. Something over itself always equals 1. If we do x squared, no matter what x is, x over x times x over x, those x's will cancel, leaving us with x to the 2 minus 2, so x to the 0, and that's going to equal 1. So, I should go back here. 5 to the 7th over 5 to the 7th. 5 to the 7 minus 7. 5 to the 0 is 1. X to the 2nd over x to the 2nd. X to the 2 minus 2. X to the 0 is 1. So the rule when dividing powers with the same base and same exponent, subtract exponents to get 0. Something raised to the 0 is 1. Okay, so on our own here, 6 to the 5th over 6 to the 5th, that's just 1. Negative 43 to the 0, that is 1. X to the 4th over x to the 4th is 1. Now, I want to show you some that are going to look similar. And sometimes we just have to be really careful over what they're showing us. So if I have x to the 0, no matter what x is, that's 1. That 0 belongs only to x. If I have 3x to the 0, that 0 belongs only to x. So that is 3 times the value of 1, so that equals 3. Now, if I put something in parentheses, like 4y to the 0, no matter what 4y is, when we raise it to 0, it's going to equal 1. So those are just some you might see, and when you go to algebra next year, you're going to see more examples like this. This next section is about negative exponents. So Sometimes we're going to end up with negative exponents when we do some subtraction, and we're going to make sure that when we finish our answer, we write our answer with a positive exponent. So I've got 2 to the second over 2 to the fifth. And when I'm canceling, so this is our expanded form, 2 times 2 over 2 times 2 times 2 times 2 times 2. And we cancel those 2's, and that leaves an empty space in the numerator, but you should remember that you can always throw a multiplier of 1, because that's not going to change the value. So that's going to create a space for a numerator of 1, and we're going to just count how many 2's we have left. We've got 3 left once we've done our canceling. And over here we can see that when we've subtracted our 2 minus 5, we're going to get -3, and then we're going to move that to the denominator and make it positive. So a to the third over a to the eighth. So I'm going to put 3 copies of a over 8. 1, 2, 3, 4, 5, 6, 7, 8. And when I cancel those, cancel, that leaves an empty space, and I need to put a 1 there to hold that spot. So what I'm left with is 1 over a, which is 1 over a to the fifth. And if we use the rule, a to the third over a to the eighth, we're going to take a to the 3 minus 8. So a to the -5 becomes 1 over a to the 5. So a general rule for what a negative exponent means what to do. We'll think about this as what do we do when we have a negative exponent? When I have a negative exponent, it creates a fraction. The negative moves to the denominator. Let's say the negative moves to the other part of the fraction, actually. And becomes positive. Okay, so we can see that in these next 3 examples. So our first example, we've got 7 to the 4th over 7 to the 9th. So we're going to take 7 to the 4 minus 9, and that's going to give me 7 to the -5. So I'm not going to leave my answer. We want no negative exponents in our answers. So 7 to the -5th becomes a fraction with 1 in the numerator and 7 to the 5th in the denominator. X to the 4 minus 6 is x to the -2, which is going to become 1 over x to the second. And the last one, we've got a negative in our denominator. So what's going to happen is that we're going to bring this denominator to the top, and we're going to make that exponent positive.